In the last video we looked at the convolution of two functions f and g. We showed that if f and g are both causal functions, then f and g can be written as f of t times u of t and g of t times u of t, and their convolution is given by the integral of 0 to t of f of t minus x times g of x with respect to x. Let's take this example here. F of t equals t times u of t and g of t equals t squared times u of t. So we just apply this definition. So we have to get f of t minus x, so we just replace t in t times u of t with t minus x. And we write down g of x, so we just write this as x squared times u of x. You can see that we don't need the u's in the definition, because over the interval from 0 to t, where t is some positive number, both the u functions, u of t minus x and u of x, are equal to 1. So we just get 1 times 1, which is 1. So here we're just following the definition. Inside the bracket we have f of t minus x without the u, and after it we have g of x without the u. So we're integrating with respect to x, so we treat the t as a constant. So first we want to integrate t times x squared. Well, t is just a constant, we leave it to one side. Integrate x squared with respect to x, we get 1/3 x cubed. The next term is minus x cubed. If we integrate that, we get minus 1/4 x to the power of 4. And our limits are from 0 to t. So we plug the upper limit t in for x, and we get 1/3 t cubed by t, that's 1/3 t to the 4. And here we get 1/4 t to the 4. Then plug 0 in, and we subtract off 0 here. So we end up with 1/12 t to the 4. Let's take this example here. F of t is t times u of t, so f of t minus x is just t minus x, we leave off the u part. G of x is sine of x. Now in this we have a product of functions, so which of them will we call u? Well, we can use our LIATE rule, where a stands for an algebraic term and t stands for a trigonometric term. The algebraic term is t minus x. T is just a constant, so x is the algebraic term essentially, and t is the trigonometric term, which is sine of x. A comes before t, so we let u equal t minus x. So we can see that du equals dt. Then we set dv equal to what's left of this differential, which is sine x times d of dx. And if we integrate for v, the integral of sine is minus cos. So in our formula we have to multiply u by v, so we have to multiply t minus x times minus cos x. That's what we get here. And we have to apply our limits actually here from 0 to t, and here of course. And then we've minus the integral of v, which is minus cos of x, that's this here, times du. We have to be careful here, made a mistake here. The variable is x, the independent variable here is x. We treat t as a constant, so du equals minus dx. Or you can say du dx equals minus 1, and from that you get du equals minus dx. So that's where the minus 1 dx is coming from. So we have our v minus cos x times du, which is minus dx. And these two minuses give a plus, we just end up with a minus sign. We have to integrate cos of x from 0 to t. The integral of cos is sine. We apply our limits 0 to t. As for this one here, we plug t in for x. Well, we get t minus t is 0 here. So we have 0 and then a minus sign. Then we have all of this with 0 in for x. So what's that going to give us? Well, it's going to give us minus t minus 0. Well, that's just minus t times the cos of 0. The cos of 0 is 1, so we get minus t times 1. So we get minus minus t is plus t. Applying our limits here, we get sine of t minus sine of 0. Well, the sine of 0 is 0. So we end up getting t minus sine of t. So the convolution of the functions t and sine of t is t minus sine of t. Now in this example we are going to reverse our two functions. So instead of getting f star g, we will get g star f, and you will see that we'll get the same answer. So to get the convolution of g and f, we have to get g of t minus x. Well, that's going to be sine of t minus x multiplied by f of x. Well, f of x is just going to be x. We leave out the u's. And we have to integrate from 0 to t with respect to x. So we have a product of two functions of x. And we have to use integration by parts. So we have to get this in the form integral of u times dv. We let u equal x. So x is the algebraic term. Sine function is the trigonometric term. And in the rule LIATE, like before, a comes before t. So we set u equal to the algebraic term, which is x. We need to get du, so we need to differentiate u with respect to x. So du dx equals 1, so du equals dx. We need to integrate this to get v. Now the integral of sine is minus cos. And we divide by the derivative of the angle. So if we differentiate t minus x with respect to x, well, the derivative of t is 0. The derivative of minus x is minus 1, so we have to divide this by minus 1. The reason why we divide is, well, if we were to differentiate this, we would apply the chain rule. The derivative of cos is minus sine, and we do minus sine of t minus x. And then we'd have to multiply by the derivative of the angle, multiply by minus 1, because t is treated as a constant here. Anyway, we're going to end up with cos of t minus x. So we plug in here, we have u times v. So we have x times cos of t minus x, limit 0 to t, minus the integral of v times du, that's cos of t minus x times dx. So we plug the upper limit t in here, and we get t times cos of 0. Well, t times the cos of 0 is t times 1, which is t, and then we have a minus sign, then we plug the 0 in. Well, if we plug 0 in for x, we just get 0. Over here, if we integrate the cos function, we get minus sine of t minus x divided by the derivative of the angle, which is minus 1. So we get minus sine of t minus x divided by minus 1. I'm sorry, the integral of the cos function is sine. We actually get sine of t minus x divided by minus 1. That's what we get when we integrate cos of t minus x with respect to x. The derivative of minus x is minus 1. And this minus out here give us the plus here. So we apply our limits from 0 to t. If we plug t in for x, we get the sine of 0, which is 0. Then we have a minus sign, then we plug 0 in for x. So we end up with, if we plug 0 in for x, we get sine of t. So we get 0 minus sine t. So we end up with t minus sine t. That's what we got for the convolution of f and g. So f star g is the same as g star f. Now we're going to see convolution in action for getting inverse Laplace transforms by considering this example. F of t equals t, g of t equals sine of t. We're going to get the Laplace transform of both of these functions. We've already got the convolution of these two functions. So f of t is equal to t, so we use this rule here from the table with n equal to 1. So t to the power of 1 is t, and we'll have 1 factorial, which is 1 over s to the power of 1 plus 1, so we get 1 over s squared. As for g of t, well, that's sine of t, so we just look that up here. So there's the sine of t, so the coefficient of t is 1, so we have 1 over s squared plus 1 squared. Now let's look at the Laplace transform of the convolution of the two functions. The convolution is t minus sine of t. The Laplace transform of t is 1 over s squared. The Laplace transform of minus sine t is 1 over s squared plus 1. Now it turns out if we multiply L of f of t by L of g of t, we will get L of the convolution of f and g. So here is the Laplace transform of the convolution of f and g. We just get a common denominator. Just multiply the two denominators together, and we multiply s squared plus 1 by 1. That gives us s squared plus 1. Then we have minus s squared by 1. So we end up at 1 over s squared times 1 over s squared plus 1. But that's just L of f of t times L of g of t. So to get L of the convolution of two functions, we just get L of each function and multiply the results together. So as we saw in the first video, or the previous video on convolution, if we know the inverse transforms of two functions, big F and big G, we can get the inverse transform of the product of them by getting the convolution of f and g. That just comes directly from this here. L of the convolution of two functions is the product of the transforms of f and g. But the transforms of little f and little g are big F and big G. So we could start with this here and take L inverse of both sides to get this result over here. It's actually easier to start with this and then deduce this. Next we will get the inverse transform of 6 over s into s squared plus 9 using both partial fractions and the convolution theorem. Let's get the partial fractions of this here. Now I won't go through this in detail, I'll just look at the result. So the factor that's linear, s to the power of 1, has a constant numerator, and the factor that is quadratic, s squared plus 9, for this fraction the numerator is linear in s. It's going to have the form as plus b. Anyway, if you go through the partial fraction expansion, you'll find that the constant here is 2/3 and the coefficient of s is 2/3. The constant on top here is that must be 0. So we get the inverse transform of each of these two fractions, so we take 2/3 out. Inverse transform of 1 over s is actually u of t. It's just equal to 1 for positive t. And this here has the form s over s squared plus a squared, where a is 3. So the inverse cos of such a thing is cos of at with a equal to 3. Now let's use the convolution theorem. So we can write 6 over s times s squared plus 9 as a product of two functions of s. We can write it as 2 over s times 3 over s squared plus 9. The reason why we write it like this is because we want this thing to have the form a over s squared plus a squared, so where a is equal to 3, and we know the inverse transform of such a thing is sine of at, where a is 3. So that's why we factorized 6 as 2 times 3 in writing our function as a product of functions f and g. So we found little f of t and little g of t. We know the convolution theorem says that the inverse transform of big F times big G is the convolution of f and g. So we need the convolution of 2 and sine 3t. So we have to integrate from 0 to 2 this function at t minus x, so we have to get u at t minus x, times g of x. So we have sine 3x here. Now I explained in a previous video that if t is positive, then u of t minus x equals 1 for values of t between 0 and t. U of t minus x is equal to 1 for values of x less than t. So it'll be 1 in this interval here, 0 to t. U of x equals 1 in this interval 0 to t also, because u of x equals 1 for x greater than 0. So both u's are 1 here for positive t. So we'll just end up integrating 2 times sine of 3 of x. We can just drop out the u's. Now what if t is negative? This is something I didn't state in the previous video. Well, if t is negative, we can see that u will be 0, because u of x is equal to 1 for x greater than 0, but it's equal to 0 for x less than 0. So u of t will equal 0. So this will be 0, so the whole thing will be 0. So the convolution is 0 if t is less than 0. And the convolution is integral of 2 sine 3x with respect to x from 0 to t if t is positive. So we just have this straightforward integral to perform. The integral of the sine function is minus cos, and we divide by the coefficient of x. So we get minus 2/3 cos 3x. So we just plug in the limits, we get minus 2/3 cos 3t minus or plus 2/3 cos 0. That's plus 2/3. And that's the same as what we got up here using partial fractions.